Today, let's take a look at ellipses. So an ellipse is a curve formed by the intersection of a plane and a curved surface like a cone. So for example, it may be like taking a cone and intersecting a plane. That intersection creates what is known as an ellipse. So an ellipse has two axes, an x-axis and a y-axis, and one of those axes is going to be considered the major axis. And major axis is basically defined as the widest portion of your ellipse. So if it is long left and right, then we say that our x-axis is our major axis because that is the greatest distance across my ellipse. However, if it's taller than it is wide, then we say our y-axis is our major axis. And this comes into play when we start looking at the foci and movement around the center of your ellipse. So an ellipse is created using 2 points called a foci, and all of the values that sum up to their distance. So it's like taking 2 points and putting a string in between that's just a little bit longer, and then using it to kind of create this football-like shape or this oval about those 2 points. Now your foci is just plural for focus, so you can have one focus point in a conversation or 2 foci. It will always lie on your major axis. So if your ellipse looks like this, where it's longer left to right, then your foci are going to be located on the far left, or on the left and the right side of your ellipse on that major axis, the x-axis. If your ellipse was tall looking, like so, tall and skinny, then your ellipse would lie on the upper edge or the lower edge of your ellipse. So an ellipse has 3 pieces of major information. You have your foci, which is that distance, and you have an A value and a B value. Now, I'm not going to refer to these as A or B. I'm going to refer to these as long and short because A and B are interchangeable. A simply represents your longer distance. So if you have an x-axis that is your major axis, then your A value is going to be associated with x. However, if your ellipse is tall, then your A value is going to be associated with y. And so instead of just having to think about that flip-flop, I'm just going to use the phrases short and long. So your foci, it is a measurement of distance. So it kind of looks like our Pythagorean theorem, except that instead of adding them, we're looking for the difference of those squares. And that distance we are going to add and subtract from the center point to give us that distance value. So it is a relationship between your long and your short side. So a standard form of an ellipse comes in 2 forms. Again, I just talked about that A value. So you have x squared divided by a squared plus y squared divided by b squared is equal to 1. All ellipses are set equal to 1. Or you can have x squared over b squared plus y squared over a squared equals 1. So again, those A and B values, they interchange. But basically what A represents is your long and B represents your short. So in my first standard form, because my A value is associated with my x squared, then I know that I have a x-axis that's going to be my major axis because my larger denominator was partnered up with that x value. Whereas in the second ellipse, my A value is tucked underneath my y squared. So I will have a larger denominator, a larger number in the denominator underneath my y value. So that will kind of signify, okay, I've got a y-axis, that's my major axis. So it's tall and skinny instead of short and wide. So let's take a look at one example. I'm just going to kind of talk through it and then we'll do a couple together. So I have x squared divided by 4 plus y squared divided by 16. So one of the first things that I want to look for is my larger value in my denominator. So my larger value is 16. So this is associated with my y squared. So that's going to signify that I have a tall and skinny ellipse, and my major axis is going to be my y-axis. So my foci is going to be lying on the vertical movement. It's going to be a vertical movement from my center. So my vertices, those far corners, and it's not really corners because it's a round edge, but the farthest edge, left to right and up and down, come from your denominators, your values underneath the respective variable. So if I'm looking for my far left and right value, my x values, I'm going to work with my number 4 because x is going to be associated with that 4. And in order to find the distance, we're simply going to take the square root. Now the square root of 4 most commonly is the number 2. If we're looking at distance, typically we do look at the positive values. But in this case, we are going to be looking at both the positive and negative value because we need to move both left and both right. So the plus and minus sign kind of represent movement. So plus 2 represents a positive 2 movement or 2 units to the right, while negative 2 symbolizes 2 units to the left. And since at this point my ellipse is centered at 0, 0, I can take my x value from my order pair 0 and add and subtract 2. So I get 2 x vertices at 2, 0 and negative 2, 0. The same is true for your y vertices or your vertical vertices. Y in this case is associated with that number 16. So in order to find the vertices, we're going to take the square root. That's going to give us the distance from the center. And the square root of 16 is both plus or minus 4. So I know I'm going to be moving up 4 units from the center and down 4 units from the center. Since the center of my ellipse is currently at the origin, I have 2 vertices at 0, 4 and 0, negative 4. Now the foci are those 2 focus points. You can imagine it like if you had a circle and you squished it from top to bottom, that it would squish out low and flat. And the more you squish down, the farther it stretches out. That's kind of how the foci work. If I was to take the same circle and squish it together, so taking the left side and the right side and pressing inwards, it would become tall and skinny. And the more that I press in, the taller it becomes. And that's kind of where the foci lie. So I am going to start by using my foci formula, c squared equals my large value minus my small value, or a squared minus b squared, or vice versa. So those large and small values, they still come from my fractions. So my larger denominator was 16. And my small denominator was 4, so if I take the difference of 16 and 4, I get 12. I don't want c squared, I only want c. So I take the square root of 12, and that leaves me with, when it's simplified, 2 square roots of 3. Because I am looking at movement, then I can say that I have both a positive and a negative. Now, the foci, remember, is the distance from the center along the major axis. So when we come back up here and we look at this particular example, my major axis here was y because my larger value lied underneath my y in my fraction. So I start at the center at 0, 0, and I add my foci to my y value. So in this case, 0. I'm going to both add and subtract my foci, which is just a distance, giving me my foci at the coordinates 0, 2 square roots of 3 and 0, negative 2 square roots of 3. So if I were to graph that, I would need all 6 of those points in order to graph that, and plus my center, so 7 points. If I wanted to know the entire distance from left to right of my ellipse, so if this was my ellipse and I wanted to know my horizontal distance, I would simply find the distance between these 2 points. So I had 2 units to the left, 2 units to the right, made 4 units in total. If I wanted my vertical distance, I would look at the distance between my top and bottom. So I went 4 units up and 4 units down, giving me a vertical distance of 8. So let's work one of these examples together. So I've got the function 24x squared plus 8y squared is equal to 96. Well, all ellipses are going to be equal to 1. So one of the first things I want to do is divide by 96 so that I have this in standard form. So I have 24 divided by 96. If you put this in a calculator, you can get a reduced fraction. It does reduce down to 1/4. So x squared over 4. 8 over 96 reduces down to 12, or 1/12. And 96 divided by 96 is 1. So it's currently sitting in standard form. So the place to start is to look at those numbers in the denominator of your fractions. You're looking for the greatest value. And so my greatest value is 12. It is tucked up underneath my y. So I know that this is going to be a tall ellipse and that my y-axis is going to be my major axis. And it's important to identify that early so that you can know which direction you're going to be moving when you look at plotting your vertices or your foci. So now that I've identified my major axis, I want to look at both my horizontal and my vertical vertice. So my x value is going to be equal to the square root of its denominator. This denominator here is 4. So I'm looking at a horizontal movement or horizontal distance of both plus and minus 2. So again, 2 units to the right and 2 units to the left. My vertical vertices are going to be, again, located at the square root of its denominator, which is 12. Now, 12 is not a pretty whole number, perfect square. So I'm going to break it down. It does break down into 3 times 4. And 4 breaks down into 2 times 2. So I know that my square root of 12 is going to be both plus and minus 2 square roots of 3. So at this point, it is centered at 0, 0. We're going to take a look at an example in just a moment about one that's not centered at 0, 0. And so my ordered pairs are 2 units to the right and 2 units to the left of the center. So both negative 2, 0 and positive 2, 0. And the same thing with my y. It is both positive and negative 2 square roots of 3 in the vertical direction from my center. So I get 0, negative 2 square roots of 3. And 0, 2 square roots of 3. From here, we can find our foci, or our c value. So c squared is going to equal my large minus my small. And those are the values underneath my fractions. So c squared is equal to 12 minus 4. 12 minus 4 gives me a value of 8. And if I take the square root of 8, 8 breaks down into 2 times 4. 4 breaks down into 2 times 2. So my square root of 8 will break down into both plus and minus 2 square roots of 2. And again, this foci is the distance from the center along the major axes. And earlier, we did identify our y-axis. So if I look at my center point, my center is currently at 0, 0. So my foci is going to be on my major axis of the y-axis. And I am going to travel both in the positive and negative direction, 2 square roots of 2 units. So my foci will be located at 0, negative 2 square roots of 2, and at 0, positive 2 square roots of 2. So that is how you can take a look at any kind of ellipse formula here, function, and tell me or identify, is it tall? Is it wide? Where are my vertices? How wide is it? So if I wanted to know how wide, it would go from negative 2, 0 to positive 2, 0. So it's 4 units wide. It's 4 square roots of 3 units tall. And it's got foci located at both positive and negative 2 square roots of 2 on the y-axis. So sometimes our ellipse are not located at the center. Sometimes they're located somewhere else. And that somewhere else is H and K, or HK. H represents your horizontal shift, while K represents your vertical shift. So your standard form kind of looks a little different. It does incorporate the H and the K. So X minus H squared and Y minus K squared. When we were looking at the examples earlier, we didn't have the H and K, and I told you it's located at the origin. So your H and your K value would both be 0, and they would cancel out. So here we go. We're looking at one here. One thing to note is be really, really, really careful when you identify your center, because our eyes will deceive us. So right now, if I'm looking at my H value and I'm looking at my K value, I would be very tempted to write -1 and +4 because that's what my eyes see. However, the standard form includes the subtraction symbol, which means that your symbols in your actual function lie. They're going to be the opposite. So I don't see a -1, I see a +1. And I don't see a +4, I see a -4. Because H and K are going to take on the opposite symbols when you're identifying the center of your ellipse. So I've got my center. I look in my denominator. This time my X value has the greater denominator, so it is going to be a wide ellipse, meaning that the x-axis is going to be my major axis. So whenever I am moving or locating my vertice, I'm going to be using the center. But when I am also identifying the ordered pair for my foci, I'm going to focus on the x value of the center of my ellipse. So let's go in and calculate the vertices. So my vertices, if I look at my horizontal vertices, I'm going to be looking at the square root of my x value, so 144. So x is plus and minus 12. So this is going to be a horizontal distance, 12 units to the right and 12 units to the left from the center. So this is distance from the center. So the center is located at 1, -4. So I need to move my x value both to the right and to the left of the center of my ellipse. So I have a left and right or horizontal vertices located at 13, -4, and -11, -4. I'm going to do the same for my vertical vertices, my y values. So my y is going to be the square root of 81, which gives me a up and down movement of a 9, so +9 and -9. I'm still going to use the center, because remember this is the distance from the center. And I'm going to take my y value and move up 9 units. And I'm going to take my y value and move down 9 units. So I have vertices at 1, 5, and 1, -13. So now I've got the farthest point to the left and to the right of my vertices, the farthest point from the top to the bottom, and now I need my foci. So remember, c squared is going to equal my largest denominator minus my smallest denominator. So c squared is going to equal 144 minus 81. And 144 minus 81 gives me a value of 63. So if I take the square root of 63, I do not get a whole number. It's not a perfect square. But it does break down into 7 times 9, and 9 breaks down into 3 times 3. So the square root of 63 is going to be plus or minus 3 square roots of 7. Again, this is going to be measured as distance from the center along the major axis, which is all the way back at step 1, the very first thing that we did. So we did recognize that our x-axis is going to be our major axis. So I'm going to start at my center, and my center is located at 1, -4. Because my x-axis is my major axis, I'm going to take that value and add my foci, so moving to the right, and moving to the left. And that is it. So sometimes, like for here, you cannot combine those. Those are two different kinds. Those you have a rational and an irrational number. So sometimes we do combine these down, and you might see it written as 1 plus or minus 3 square roots of 7, -4. We could take a look at another one. This one will be pretty simple. We've got some beautiful, nice whole numbers here, some perfect squares. So one of the first things I want to identify, is my center. My center is located at -2, -4. Just a reminder that these signs lie. So not +2, but a -2. And I also want to identify my axis, my major axis. So 64 is greater than 36. So we have a wide ellipse, which means that my x-axis here is going to be my major axis. So I will use my major axis to move my foci. So I go to calculate my vertices, and I want to look at my x values first and then my y values. So x is equal to the square root of its denominator, so 64. So I'm going to have a positive and negative 8 unit distance between my far left and my far right side. So if my ellipse has a center located at -2, -4, Then I'm going to take my x value and add 8 and subtract 8. So moving 8 to the right, 8 to the left, giving me an ordered pair of 6, -4, and -10, -4. I'm going to do the same thing for my y's. So the square root of the number tucked up underneath. So I have a vertical distance of both plus or minus 6. So 6 units up from the center and 6 units down from the center. So I'm going to take my y value and add 6 to it. And I'm going to take my y value and subtract 6 from it. So I have an ordered pair -2, 2, and -2, -10. The last thing I need to calculate is my foci. So c squared is equal to the largest denominator minus the smallest denominator. So my largest denominator is 64. My smallest denominator is 36. That gives me a value of 28. And if I take the square root of 28, 28 breaks down into 7 times 4. 4 breaks down into 2 times 2. So I have a foci or c value of plus or minus 2 square roots of 7. Again, our foci is distance from the center. So here's my center along your major axes. So we had determined that our x value, our major axis was our x-axis. So we're going to take that number and I'm going to add and subtract the distance of my foci. And since it is an irrational number, I can leave it written just like that.